In this video, I'd like to talk about Solid Edge feature patterning. Patterning is probably one of the areas of Solid Edge that is most unlike SolidWorks. Some of it will look very familiar, and some of it will require a different approach. The pattern tools can be found on the Home tab in the Pattern group. There are 4 types of patterns. One is simply called Pattern, which includes rectangular and circular patterns. One is called Pattern Along Curve, which has 1 and 2 direction curves. And there is also Pattern by Table, and the final one is simply Duplicate. Pattern starts out looking rather familiar. The command bar step type interface wants you to start by selecting a feature to pattern, and we'll just select this hole to begin with. Then click on Accept, and Solid Edge wants you to create a sketch. So you click on a plane to put the sketch on, or a planar face in Solid Edge fashion, and Solid Edge kicks us into the Sketch Rectangular Pattern tool. Your instinct here might be to go for one of the sketch tools that you're familiar with, but you'd be wrong. You need to stick with the tools that Solid Edge is providing for patterns, and that includes a rectangle for rectangular patterns and a circle for circular patterns. These tools work like sketches, but just be clear that they are not your regular sketch functions. If you want to create a rectangular pattern, just use the default rectangle tool and click and drag out the rectangle that you want to create. If you're looking to create what in SolidWorks is called a linear pattern, then you'll want to change one of the X or Y numbers to 1. You could also use a curve-driven pattern and just use a straight line. In this case, you want to do a 3x5 pattern, and that's showing up with blue dots. You can use the stagger option, which comes with either row or column offsets, and set this back to none. If the reference point is not selected, you should select it. It's shown here with the X. You can suppress occurrences by clicking on the blue dots. Get back to the pattern parameters page by clicking the green check or using the right mouse button. You may also need to click on the pattern sketch to access those parameters. You have 3 options for the spacing: fit, fill, and fixed. For fixed, you just specify the spacing and number of occurrences, and it will resize the rectangle according to the dimension. Fit will fit the number of occurrences, as Solid Edge calls them, into the sketch that you have drawn. You can specify an overall size and even rotate the pattern. When you've got what you need, click on the green check mark to exit the sketch. Remember these 2 occurrences that were suppressed earlier. To get these 2 occurrences back, click on the pattern in the Pathfinder and then select Edit Profile. Next, you'll need to select on the pattern sketch itself and then click Suppress Occurrence. And from here, you'll be able to reselect those 2 dots that you deselected earlier and press the green check and finish. If you want to add this small keyway to the pattern, just click on the pattern in the Pathfinder, select Edit Definition, click on Select Step, and then pick a face of the keyway feature. Then right-click to accept and finish. The Smart option on patterns can pattern the end condition in a from-to extent on the extrude feature. For example, this cutout was extruded offset from the curved face. A Smart pattern results in the patterned holes each being offset from the curved face along its length. A Smart pattern can be created using a from-to extrude. Let's start by creating the from-to extrude. I'll start with the Extrude command, select the sketch, right-click to accept, and move on to the Extent step. Under the Extent, we will select From To. The tip for this feature says select from surface or right-click to extrude from the profile plane. So because we've already got the profile plane highlighted, I'm just going to right-click. And that moves me on to the To surface. The To surface will be the curved bottom face, and I'm going to say we want to offset by 0.5 from that. And I'll select this bottom surface. we get an option of which way to offset, and so we'll come up short of that. And so now you see we've gone from the top surface to an offset of 0.5 from the curved surface. So we'll click Finish and Cancel. Now from here we can create a linear pattern. Pattern will be of this feature. Right click or green check to select. The sketch step for the sketch pattern is this top face, and automatically kicks me into the rectangle command. And with this, we'll draw the rectangle. Make sure that we have 1 in the Y direction and hit the green check. We're going to use the smart pattern because a fast pattern is just copying the existing geometry. This is like the geometry pattern in SolidWorks. So we'll use a smart pattern and click Finish. The pattern along curve is like the SolidWorks curve-driven pattern. In Solid Edge, this is a little bit different from other types of features. Other features allow you to draw a sketch that you need for the feature while you're creating the feature, but the along curve pattern requires you to create the sketch ahead of time. So that's what I've done here. I've created a sketch with 2 arcs. These could be arcs or splines or straight lines. You could also use edges and other entities. So let's get started looking at this feature. Let's create the along curve pattern, and we'll start by selecting the feature, the hole that we're going to pattern. Right click to accept, and in the select curve step, we'll select the first curve, click to accept, and now we need to establish an anchor point, which will be the end of the curve right in the middle of the hole feature. And next we need to establish a direction for the pattern, and we'll accept that when it's all correct. Notice it skips right over the path curve step, and that's the second direction, but most of your patterns will be single direction, so you have your fit, fill, and number of instances. Also, you can suppress occurrences, and we've seen all of this before. But let's go back and use this path curve step. This allows you to establish a direction to curve, and you can see you can create very complicated patterns using this. Pattern by table is also very powerful. You can start by selecting the hole and the little keyway to pattern. Then accept and select the coordinate system. Solid Edge gives you the option to browse for an existing Excel file, and you can link to that. Solid Edge is going to require that you use Excel to build the instance table. It knows where the reference feature is, but we need to tell it where each of the individual features is going to be. That includes an X position, a Y position, and a rotation in degrees. The X and Y are relative to the part coordinate system or whatever reference point you have established. Once you get all of the data entered in, save it and then browse to that location. Make sure it is linked, and Solid Edge will bring all of that information in and create your features. You can see how these features have each rotated slightly according to the angles established in the Excel file. When modeling in Synchronous, to create a pattern, you start by selecting a feature or a set of faces. Once you have done that, all of the familiar pattern and mirror tools become available in the ribbon. Once the pattern is created from the Synchronous feature, you can edit parameters on the screen just like you would in ordered modeling. The pattern has a call out, which you can click on to edit the X occurrences and Y occurrences. You can edit the spacing. You can even edit the original hole, and all of the patterned objects will update. Synchronous will also recognize existing dumb patterns and add parametrics to them. Say a pattern existed in an imported part. The recognized patterns will parameterize those for you so they are editable as patterns. If you had made a part in ordered mode and moved it into Synchronous, the patterns would already be parameterized for you and still editable as patterns. To accomplish this, you first recognize the features on the part as holes, and then you can recognize the holes as a pattern. The pattern can be changed using all of the parameters of standard patterns. Thanks for watching.